Hey, Timo.
Hello, Michael.
Hey, it's great to be here with you. I'm super excited to talk about async Python.
Yeah, same. Good to be here.
Yeah, it's great to have you here. We've spoken a little bit through GitHub. I think it's odd, but also kind of awesome how many connections are made through places like that, right? Like we've never met in person, but we
True,
previously
yeah.
chatted about some async things on GitHub.
Yeah, it's always nice to
So
kind of see the same people again, which you met like online in a call or something
yeah,
and talk about something. It's
yeah,
pretty cool.
that's why I really enjoy going to conferences because you're like, oh yeah, you're the person I've been talking to
Yeah,
for 6 months.
yeah,
Yeah,
absolutely.
yeah, cool. Well, I'm super excited to talk about all the awesome async Python things that you've curated. Before that, though, let's just get into your background. What's your story? How did you get into programming in Python?
Yeah, so I started programming, I think when I was around 10 years old. At the time, I was exploring at an offline computer from my parents, which didn't have a lot of like things on it, but there were a few applications. And one of those were, I think it's called Front Page, like Microsoft Front Page and Publisher, which is
Yes,
like,
it was
you know,
like Microsoft Word for creating websites. It was insane.
exactly. Yeah, exactly. So I was like playing around with this and just, exploring whatever was there because I didn't have any internet. Um, and yeah, that's how I got interested in like how things are built in a computer. And at some point I got internet. I kind of browsed around to see like how these websites really look like. And yeah, that's how I got into PHP and HTML and did some website stuff. And then
Couldn't you
after,
open a website in Front Page? Couldn't you like point it at a URL and say open this and it would pull down the HTML like into the editor? I think I
I don't
remember.
really remember.
What a weird piece of software that was.
Yeah,
Sorry,
yeah,
I
it
don't
was
mean to
strange.
derail. I'm just thinking back of like the early web was a weird time.
Yeah, I think I more used Publisher than I used Front Page because it was more
Yeah,
complex for me at the time, and I didn't really have any documentation or tutorials. So yeah, it was more like fiddling around and getting
nice,
something to work and something to happen. So
cool. So you found your way to PHP.
yeah, then I went to PHP, did some very basic websites like guest books and these kind of things with PHP, but nothing really big. And then after mandatory school years here in Switzerland, I started an apprenticeship at Roche. It's a pharmaceutical company. So if you've done any PCR tests lately, you probably have done that on an instrument of them. And there I was in a team where we did hardware simulation testing for software which is running on these instruments. And all these, like the testing framework around the simulation was in Python. And that's basically how I got started in Python. Yes, it's mostly like testing code and providing frameworks in Python for testing.
Yeah,
That was mainly it.
that's cool. That's a neat way where you can connect your code to physical things.
Yeah,
Testing
it's super
like lab
nice.
equipment
And
and stuff.
yeah, and the simulation at the time, it also had some 3D visualization, so you could see motors moving around and kind of
Oh,
see
wow,
pipettes colliding and these kind of things, which was pretty awesome for me at the time because it was my first job basically. And yeah, it was super cool. It was super cool. We also
cool,
built with Python
awesome.
like a distributed testing framework or testing system, kind of like you would have in Jenkins these days or any other CI system.
Yeah, they probably don't have as easy integration to actual hardware. When I push
Yeah,
to this branch, I wanted to fire up that robot. Oh, okay.
yeah, exactly. And also, like a huge problem is like error case testing. Like you can't just break a needle in an instrument while you're running something because either you get hurt
Yeah,
or it just costs you $1,000 just for breaking something for testing. So you need some kind of simulation to actually do that.
yeah, very fun. How about now? What are you up to now?
Yeah, I recently started a new job at GitLab. I'm a senior backend
Hmm.
engineer there in the configure group, and what we're doing is we provide Kubernetes integration for GitLab projects and groups, these kind of things, and also are responsible for the infrastructure as code features like the Terraform state backend and the Terraform provider, which also I've been maintaining for a year now as just like an outside contributor. Yeah, but this is mostly Go. If maybe you know, Ruby is a big player in GitLab, so the entire GitLab repo is mainly a Ruby on Rails application. So no more Python there.
Yeah. Give us the elevator pitch on GitLab. You know, is it I should use GitLab instead of GitHub or something else, or what's the value proposition for GitLab?
Yeah, I think it's a good question. What you see here also on the screen is that it's called the One DevOps platform. So it provides much more feature, I think, than GitHub in terms of like from planning to production and then monitoring an application, get like all these insights, which you cannot really do on GitHub. So you have you basically have features for all the DevOps lifecycle stages. Here, for example, you see the verify, where you have a very powerful pipeline integration. I think the open source world is happening on GitHub, but a lot of enterprises are using GitLab these days for developing their applications.
Okay, cool. Yeah, it's definitely an important piece of the puzzle out there. And how long have you been at GitLab?
Just 1 month. Actually, today marks my 1 month being at GitLab. So pretty recent.
Wow. So you're probably just starting to get comfortable with like how stuff works and how you deploy.
Exactly. It was a lot of onboarding, but I've been contributing before, so not everything was new, and I've been using GitLab as a user. So sure, it wasn't that tough, I would say.
Mm-hmm. Cool. All right. Well, let's go ahead and jump into your project.
Sure.
It's one of these awesome lists, and it's about one of my favorite aspects of Python because async.io, async and await, they let you write such neat software that really takes advantage of latency, and when other parts of the system are busy, you can just keep on going without rethinking how your code works all that much. So I'm a super fan of async and await in Python and in all the languages that use it, I suppose, because I just like the idea. But, tell us about your project, and maybe first start with like, what the heck is an awesome list anyway?
Yeah, so an awesome list is just a curated list of projects or whatever the awesome list is about. It could be recipes or whatever. And it's just trying to collect awesome pieces of that thing, in this case, async.io, which are async.io packages or projects. And you basically showcase them to the readers, and they could, take inspiration for their next project stack, or can just explore like what's out there and what people feel that is awesome. And I'm not an expert in all of these by far. So I'm more like the librarian of the list, and rely on people contributing actually their awesome projects or ideas or whatever. And
neither, as a disclaimer up front, neither of us are maintainers of all these projects, or like we're not super experts. It's more of a survey of all the cool things, and I do think that's one of the really cool powers of the awesome list. I remember the first time I found awesome Python, I was like, wow, look at all these things I didn't even know existed, right? It's not necessarily that you use the awesome list to make a decision about what you use, but it's like a good starting point for research, depending on whatever area. Like, you've broken your list into stuff about databases and about networking and about web frameworks, and as we'll see, and you go to that section you're interested in, and you're like, oh, here's my 10 research projects to figure out what I want to do.
Yeah, exactly. I think it's also nice to just once in a while browse through it and see like where the ecosystem is at, and like what new things have been popping up. So
so another thing I think maybe is worth touching on, I get the sense, although I'm not 100% sure because I'm asking you now, that these things that get put there, it's not an exhaustive list. It's more of a things that the community thinks reaches some threshold for interestingness. So under the PRs, I see you got a new one an hour ago. Under the PRs, you have please vote before these are accepted, because like what it means to accept a PR is really to add a line to a README. It's not like a super oh boy, how does this affect our overall performance? Like, there's not a lot of considerations in that regard, but the question is sort of, let's talk about whether it belongs on the list, right? How do things make it on your list?
Yeah, it's a very good question, and I've never been really strict about these rules, and maybe I should be. I don't know, but I usually put this please vote label on pull requests just to see if people are interested in this. And usually I also check things like the stars, when was the last contributions, like how many contributors are there, because if we put something here on the list and then people start using it and you burn out some maintainers of a library which just wanted to do, publish something.
Yeah.
I don't know if that would be a good idea, right?
Right. And on the other end of the spectrum, you've got, maybe there are people who publish something just for the heck of it, but there's one person, they've touched it 2 years ago, and it's not necessarily something you want to recommend if there's 5 stars and no one using it. And is it really going to be, good enough? Okay, cool. So I'm guessing it's open for people to go and do more PRs and suggest more things if they listen to the show and they're like, but you forgot about this awesome thing.
Yeah, I mean, if people are listening and have something awesome, please create a pull request. Always great to have some additions.
Yeah, cool. All right, well, let's go through it. So I think we'll just take it section by section or topic by topic. And I know you pulled out a couple things that are interesting to you. I grabbed a couple as well, and we'll just touch on them. Kind of work on that awareness and cover the broad spectrum of what's available. So we'll take it, I guess, the top section that you have here, probably the most important section, I would say, is web frameworks, right? And let me actually put this back real quick. So yeah, so for the web frameworks, there's some interesting ones. First of all, it's kind of notable, the ones that are not there yet. Maybe there's some PRs that should be making their way there, right? The really traditional web frameworks that people think about are not there, right? We don't see Flask directly, although through Court it's there, which is kind of its full async implementation. Django is not listed. Bottle, Pyramid, bunch of these older ones. But the really hot new ones are here, right? Like we've got Fast API and Sanic, and some of the others as well.
I guess people are just probably more excited about those, and then they're kind of hyped and add those, and that's probably why they end up here and not having like Pyramid or the older ones.
Yeah. Well, Pyramid doesn't have a async version, but it's interesting that Django does. And I think maybe somebody should do a PR for Django now that it actually properly supports all the way to the database layer. But until recently it didn't. And what's notable, I think, about all of these frameworks that are here on the web one, and pretty much for many of the others as well, is not just they have a capability to do async, but they were kind of born to be async, right?
Yeah, you're right, and I think also some of them, I mean, they're not all on the same level. I would say, like we have Starlet, which may be like a very lightweight framework that others kind of build on top, like Fast API, which Starlet may be more comparable to Quart than Quart is to Fast API, right? So we have these kind of different layers where people could build upon, and so it's some variety.
Yeah, and you've got a couple of WebSocket style ones in here as well that are maybe not full frameworks, but they work in that regard. Yeah, so notable to me here, certainly, I mean, Fast API is definitely taking the world by storm. It only came out a couple years ago, and it's already got 50,000 GitHub stars, and that's close to what Flask and Django have. It's certainly a popular one. Yeah, have you got any chance to play with Fast API?
I do, yeah, or I did. At my last job, we built some applications on top of Fast API, and we also at Roche we open sourced one, which is kind of nice. I always like the Fast API experience overall. Like the documentation is super nice. I think Sebastian did a great job, and also taking the extra mile to explain more general concepts than Fast API, like introduction into async IO and these kind of things, which the others do
Right.
not have. They don't need to, but it's just that you can see that they really care about the community and the users of Fast API to make it very easy to put something into production.
It definitely stands out in that regard for sure. And so Fast API is notable. I also think another one worth giving a shout out to is Starlet. Now, Starlet is not as popular, right? Having 7,000 GitHub stars. Not that this is like a popularity contest, but it gives you a sense of like how many people are using it, right? And so Starlet is its own web framework, but it is also something that can be used for the building blocks of other web frameworks, which I think is unusual for, Flask isn't like, well, take us apart and just use us. Don't actually use Flask or, but Fast API itself actually is built on Starlet. So much of what people love about Fast API, they actually love it about Starlet. It's just kind of like a pass through.
Yeah, I think for a lot of things, Fast API is just a pass through to Starlet. And that's what I meant before with that a lot of people are like comparing, or see these blog posts like Fast API versus Flask or Quart and these kind of things. But it's an unfair comparison because they're like Starlet and Quart. I think they're meant to be extended into something like going from the micro framework to your like web application afterwards. And I think you will have a better start using Fast API if you need all these features. Then it depends on the use case, I guess. But.
Right. Very cool to learn about that one. Also, Sanic. I hadn't really been tracking Sanic until recent. I had been, and then kind of didn't pay too much attention. But this is a pretty popular framework, 16,000 stars, and yeah, it's kind of got its own philosophy. It's a little bit like Starlet actually in its style.
Okay, I've never used it. I've seen it around, but I never really looked into it. So what is it that it has a different style? What do you mean?
Well, so many of the web frameworks, that's a great question. So many of the web frameworks these days are like, we're a brand new web framework. We look just like Flask, except, we're just like Flask, but we're API oriented and we come with auto documentation. We're just like Flask, but we do this other slightly different thing. They're all like, you create an app and then you say app.get or app.route on your, and you kind of build up out of a blueprint or a API router style of like separator, right? There's so many of these new web frameworks that are like highly inspired by Flask, but they don't carry over the same runtime. They carry over kind of the shell API concepts, right? And Sanic is not so much like that. So if you go and check out Sanic, say like a good getting started, let's see if I can pull up an example. They have a huge button that says get started. Maybe I should click that. So if you look at this, in order, I'm not really seeing a great little example to pull up just yet, but if you look at the way that it works is you just create functions. They're using this app.get. So I saw some, I believe that were, you just say, here's a function, here's its URL, go and call it. Right, where it's a little more assemble it back together. But yeah, anyway, it's an interesting web framework as well. A little bit different, and I think it's really nice that there's all these people attempting different perspectives on solving the same problem.
Yeah, I think it's cool, and probably depending on the use case, one suits you better than the other. I mean, it's not that fast stars that it's always the best choice, right? Maybe Quark is better for your use case because you want something very minimalistic or something you can extend in your own ways.
Yeah, and some of these, like Sanic, just added this ability to have background workers that are managed, so you don't have to go all the way to like a Celery worker type of infrastructure. Just the web framework will manage it, and I believe Starlet also has that.
Yeah.
I guess one more thing to give a shout out to is the stuff from the Encode folks. There's a lot of those appearing here. So they've got Starlet, they've got HTTPX, and UVLoop, right? Once you get one of these frameworks, you got to run it, right?
Yeah, and probably it's one of the most popular for production, I think. At least that's what we've been using, and we've been super happy. I mean, it works great. Nice. Super fast if you use it with UVLoop.
Mm-hmm. Yeah, UVLoop. UVLoop will make an appearance a little bit later as well. But yeah, I've been using UVAcorn for production also. I'm loving it. Okay. And I guess also one thing I'll put into the show notes here is, can't remember which framework had this that I pulled it up. It might have been Sanic or Starlit, one of those two. But they created a filter across the Tech and Power Web framework benchmarks that just highlight the Python ones, right? Because there's how many? 290 frameworks in this. And you're like, I don't really care what this obscure Rust, the super lightweight thing does, because it's not a full web framework and I will never use it, and so on. So it's kind of interesting to compare just the like raw basic ones or whatever. But if people are, it doesn't necessarily matter too much, but if you kind of want to get a sense of what performance looks like across all of these, you know, here's, I'll put a link to the Tech and Power benchmarks. I don't know. What do you think about these things? Does this influence you to see, oh, Sanic is above Fast API, or do you not care?
I mean, it's nice to see those comparisons and kind of see how the theory of optimization in these frameworks kind of translate to practice. But in the real world, I would say that it doesn't really matter too much, because it's probably your business logic which is slowing you down.
Yes.
And these kind of things, or latency to your database or whatever, and not the framework itself. So I would take those with salt, a grain of salt.
Yeah, it's kind of like asking, well, if I have a tight loop and I increment a number, how fast can I do that? It's like, okay, well, sure, C++ is super fast for that, but that's not what real software does. Real software interacts with all these things, and like that difference you think is so huge is like a little marginal bit over the real work.
Yeah, and I would also say that most of the people don't actually need that speed, right? Because if you may need it, you may also choose another language, or, you know, if this really is a thing for you, then yeah, I don't know if this micro optimizations between Sanic and Fast API really brings you much benefit.
I would certainly say pick the API that makes you happy, the programming API and the framework that makes you happy, and just go with that. Yeah, good advice. All right, let's see. Are we on to our next section? We are message queues.
Yeah, I haven't been a big user of any of these. I've been using the AMQP one a while ago, so I don't really know where it's at these days. But
message queues are interesting. They're a way to add crazy scalability if you've got a lot of stuff that takes a while, but you don't need the answer right away. They're pretty interesting, but I just haven't needed them much myself either. I did not too long ago speak with Min Reagan Kelly about ZeroMQ in Python, and apparently they're doing a lot of cool stuff for powering Jupyter with ZeroMQ. So it's way more interesting than I initially kind of in my mind gave it credit for. But yeah, it's a cool project.
So they're hosting Jupyter, or what do they?
They're using it. They're using it for something for like the client server communication, I thought, but it's been that's what I think I remember. But it's been like quite a long while since I talked to him about it. But yeah, we've got the AMQP one. That's the one you talked about, right? Yes,
it's the one you would use if you use RabbitMQ, for example.
Right. Okay.
These are using the AMQP protocol, and then that's where you can use this library in particular.
Right. You have the PyZMQ. That's the ZeroMQ one I was talking about, and then some others. One for like Apache Kafka, for example. But again, anytime you're talking, these are usually separate processes, sometimes on separate machines. You're doing network comms. Like if you have the word "I'm talking over a network," then async and await. I mean, async IO. Like, what does the IO stand for, right?
Yeah, and I think point being also here is that you have async IO libraries for pretty much all message queues out there these days. I mean, we every time I looked and looked for a library, it was something was out there and you could use.
Cool. All right, let's move on to the next one, which is the database stuff. So I think this is another area where you spend especially in the web apps, you're spending a lot of time waiting. So thinking about your asynchronous database driver is super important, right?
Yeah, absolutely. And I think it's not too long ago when there wasn't really good support for async IO and databases. So it's great to see that a lot of projects are now supporting it. And yeah, also you mentioned Django, which has it all the way to the. I'm not a Django user, so I don't really know, but I also guess that's a huge deal.
I think I mean, that was the main blocker, I believe, is that Django ORM didn't have an async interface. And I think it was 4.1. Again, not doing a ton of Django myself either, but I think Django 4.1, which just came out, kind of completed the whole cycle and added that.
Very cool.
Yeah. So what database drivers stand out on this list for you?
Well, I think async PG is a very popular one if you use Postgres. I've been using it, and usually you don't really see much about them actually, because you may use SQLAlchemy on top of these drivers. So I think as an end user, you may not have seen them, but you may have used them.
The only way you might see them is you put the async connection string into SQLAlchemy, and it complains that it doesn't have this package. Like, well, I guess I got to install that. Here we go. Right?
Yeah, exactly.
Yeah. So certainly the async PG one, I think, is pretty interesting. This one is from the EdgeDB folks, right? From is that Magic, I believe? Yeah, Magic Stack, like Yuri and crew over there. So the same people that do UVLoop, right? He did a lot of the original async IO work in Python itself, I believe.
Yeah, I think there's also a nice, interesting Talk Python to Me episode about with Yuri. I think it was on.
Yeah. I think I spoke to him about a year ago as well, and that was a great chat. Yeah. Let's see what else stands out to me here. So Motor. If you're doing MongoDB, then Motor is often the building block, much like async PG would be the building block for SQLAlchemy's async. Then Motor is the building block for a lot of the Python MongoDB async libraries.
Yeah, I also noticed
another
that
one,
for Redis. Yeah. The Redis one.
Which one is that? The Redis Pi?
Redis. Yeah, exactly. So I noticed a week ago or something that this IO Redis was included into the official Redis Pi library. I don't know when that happened. May have been a while ago, but I still think it's nice to have not a separate package, but like the same package you have the sync API for, and you can kind of use similar APIs so that you don't have to like rethink everything if you want to switch to async. It just makes it easier to migrate if you want to. Also move back if you for some reason. So
yeah, and some of these have I agree. Some of these have both APIs. Like for example, SQLAlchemy, you can create an async setup, connection string engine sequence, or you can do a synchronous one. And depending on what you're doing, you might like this utility doesn't want to be async, so we're just going to go and use the sync API. But your web app or API might want the async version.
Yeah.
Let's see a couple more notables here. The Piccolo one I think is pretty interesting because I really think the query syntax for this one is quite expressive. Have you played with Piccolo? I have not, but I still admire its query style.
Yeah, I recently checked it out though. And I also had the same impression that the query syntax is super nice because compared to others like Prisma, I also looked at lately. And while they have type safety with like typed dicts that, here you actually have the Python symbols or variables you can use, which is, I think, a little bit nicer than having strings, even though they can be auto-completed.
Yeah. And when you do refactoring, like it understands what's going on. So just for people listening, for example, to do a select statement, I would say await because it's async. Band would be the class. You say band.select, then band type .name, and then where band.popularity greater than 100. A lot of these ORMs and ODMs have like janky syntax to push operations into it. So for example, in Mongo engine, you would say popularity underscore GT equals 100. So popularity greater than 100, but you're saying equals. You don't want equals. You want the greater than symbol, right? And this is like exactly the same meaning in SQL as it is in Python, which I just really like that.
Yeah, and it's also super cool if you're, entering a code base and you see these kind of things, because it even if you don't know Piccolo, like you would understand what's going on, which
Right,
I think is a good aspect of a nice API.
It is. So Brandon out in the audience has a question. It says, so we can use async PG in place of psycho PG too? I haven't done enough with this, but what are your thoughts? Do you have any ideas?
I'm quickly checking. I'm not sure if the latter one really is async.
Yeah, I think the deal is the latter one, Psycho PG2 is not async.
Yes.
And so that's what, say, SQLAlchemy would use if you had created a synchronous connection. But if you wanted to do the async version, then you would have to use the async PG foundation for it, basically. I think that's my understanding, but I do more MongoDB than Postgres, so.
I think so too, but I wouldn't really know because I've always or lately been using async only. So
yeah, exactly.
It's not the only thing you would have to change, right? You would also have to adapt your code and put the weights here and there and make your code async. You can't just replace the query string and then expect it to work.
Yeah. All right. So one other one here that I think is probably noteworthy to put in the database drivers, and I'd like to hear your thoughts on this as well, is the AIO SQLite.
Yeah.
Right. And it's on one hand interesting because SQLite doesn't really do much concurrency. So you're like, well, that's silly. Like, why would I ever want to use AIOs, like the async IO with it if it doesn't really do that? But if you're writing a web API or website or something that uses SQLAlchemy, and you want to on dev use SQLite just for like a simple test, and you want to use Postgres in production, well, guess what? Your async code will fail to run on SQLAlchemy unless you have AIO SQLite as the foundation, like we just talked about. So it kind of allows you to still test your code and run it, even though you wouldn't necessarily directly use it.
Yeah, I think we've always been using AO SQLite for testing purposes. It's super nice because you can use like in-memory databases and don't need to worry about the setup too much, and it just works basically. Need to be careful though.
SQLite's really nice.
Features.
Yeah, because it's not exactly a match, right?
Exactly. So we had the case where it worked in testing and in CI and then broke in production because we haven't been using. Or testing against Postgres.
All right, let's move on to the networking section. All right, so what stands out? There's not that many on this one. This is not overwhelming like the database thing, right?
Yeah, I think probably a lot of people know is HTTPX, which is a super nice requests-like package for making HTTP calls. It has a similar API. And the good thing, or what I really like, is that you can use it in sync and async, and the API looks pretty much the same. So if you want to switch from sync to async, I think it's a delight to use it.
Yeah, you can just say httpx.get, just like you can with requests, which is great. And then if you want the async version, do they have an async example? It's super easy to quick. I think you just create like an async client and then call the same functions on it. Yeah.
Exactly.
Yeah. Here you go. Let's see. Exactly. Much like requests where you create like a client, you just say, or a client session, I guess it's called. You say, create an async client, then you await the client.get. Yeah. It's always interesting to me how libraries decide to add on a sync and let me rephrase that, a synchronous and a non-synchronous version, like the both variants into the same library, right? Do you see people doing that successfully? Like, do you see any patterns that you really like when they do that?
I think I actually like how HTTPX is implemented in that regards. I didn't dig much in the code base, but like you have the same like protocols for the API so that you can reuse them easily and kind of interchange I think the transport layer in this case. Yeah, it's super nice. But for my own libraries, it always bothered me that there is no really nice API to provide both in like the same function. Like you couldn't reuse the function name in an async version or the method name, right? You need to have another class with it.
Right.
But I guess that's just how it is.
Right. Well, I think I think a lot of these probably grow up. They come into existence to be one or the other. And then they're like, all right, well, we kind of want to have both. So how do we add it? And if I was going to start from the very beginning, I would like to see what they're doing just for the synchronous version of HTTPX, where you just say httpx.get. Yeah. But instead of saying import HTTPX, you'd have to say from like HTTPX synchronous import HTTPX, or from HTTPX async import HTTPX, and then it's just exactly the same API, but you have to await everything versus not await. I don't know. I think they're like, if you said we'll control it at the import level, and then what you get is either all awaitable or it's all blocking. I don't know.
It's a nice pattern. It would be a nice pattern.
Yeah.
By the way, is there could you await this get? Not really. Or is there like you always need a client if you want to have async support?
I'm pretty sure for HTTPX, you have to create the client, and then you have to create an async client, then you can await it.
Okay. Yeah.
I've also seen other APIs, you have get, then you have like a get underscore async, but I kind of don't like that, since you could just do one import statement, and fix it. So I don't know. But it's really, as I'm going through all these examples that you've curated, I'm thinking like, okay, some of these have both APIs, and like, how are they making that clear to people, right? Yeah. All right. What else is noteworthy on that list? I think maybe we could just super quick touch on it. You've got an async SSH library, like literally that's its name.
Yeah, I haven't used that
DNS
one.
And a ping, right? I haven't either.
I think it's nice to have, like, here at least, to have some well, if you want to do a ping, like, it may not be obvious what to use, so I think it's a good one, or at least people consider it a good one. So I think it's nice adding those to the list. So there are a few like niche libraries on the list which wouldn't make a huge, like, they wouldn't get many votes probably if you do this, because
they're not broadly useful. You're like, oh my goodness, I've been building a DNS system. I'm so glad I found AIO DNS. But actually, some of the frameworks, like I believe HTTPX uses that under the covers. Pretty sure something I played with recently was like using AIO DNS under the covers to make its work a little more asynchronous.
Yeah, it would make sense.
Yeah. Excellent. All right, let's move on here. Testing, I think, is what I meant to talk about. All right, so yeah. Tell us about the testing story.
Yeah, so I mean, here of the ones we see on the screen, there's IO mock, there's async test, PyTest async IO, A responses, and IO responses. And I've been only using PyTest async IO, to be honest. And it basically gives you the like a decorator to mark your async PyTest or your tests as async, so that they run in an event loop. There is also now a mode you can set in the configuration where you don't need that marker. So you would, if you have a test, like you would say async def test underscore some underscore async IO code, and then your normal test code, and you would decorate this function with a PyTest mark async IO decorator. But yeah, it's not, I think, not necessary these days. You could configure it to have it in auto mode, where it basically just detects, oh, it's a coroutine. I schedule it on the event loop. Yeah, it's super smooth.
That makes a lot of sense.
Yeah,
and this is not about trying to say, well, I've got a bunch of async test functions, so let's try to run them all in parallel, like xtest or xdist or any of those types of things. It's just I have some function I want to call and test its result. It's async, so I have to await it. In order to await it, the test function itself must be async. And now, how do I run it, right? Like, now what?
Yeah, I think the other way would be kind of cumbersome to create an event loop every time and then schedule your coroutine in there, and PyTest async IO just does that for you.
Sure, you could do it, but it would make the code not look normal. It'd be like all these weird things you have to do to like async to syncify it. And we'll see some frameworks that might even do something in that regard for you. But
yeah,
I really, this is really nice. It just seems like if you're testing code that is async, clearly this is something like this is what you want. Yeah, let's see. Also mocking. I hadn't really thought about mocking async methods, but I guess you need some.
Yeah, I've done this, but I haven't used this IO mock. So there is, I think even in unit test mock, there's an async mock like a class which you can use. So I'm not really sure why you would need this.
So, this has changed 6 years ago. I wonder if the asynchronous mocking capabilities were not in the framework itself when this got created. And then probably like, you know what, we should just be able to test our own stuff. So let's fix that. Yeah, I'm guessing. Okay. Yeah, pretty nice. You mentioned UVLoop before in one of the sections. This is maybe the only section that has a single item in it, but it's a big one. UVLoop, right?
Yes.
For alternate loops.
Yeah, exactly. So you could use, if you run async IO, you can just use the one which is in like C Python, and you could just use that. But there is other implementation like this UVLoop, which is based on libuv, which is another event loop in C, and it just is super fast compared to the built-in implementation. I think it's great for production use cases.
It's so nice because in order to use it, a lot of times if it's just literally installed in the environment, things will use it. Like I believe UVacorn will use it if it finds it, and some other things. You don't even have to say, please use it. It's just like, oh, it's available, let's go. And if for some reason you need to explicitly use it, like in your code, you just say UVLoop, you say async IO.set event loop policy, and you pass over the UVLoop policy class, and now the rest of your program just uses that. It's really nice.
Yeah, I don't really know any other alternative implementations actually.
Yeah, I don't either, but it's really nice. And it basically bundles up, as you said, libuv. They've got some nice performance graphs. It says UVLoop makes async IO 2 to 4 times faster. And who wouldn't want that for free, right?
Sorry?
Who wouldn't want your async IO code to just go 2 to 4 times faster with no effort?
Yeah, and as you said, it's super easy to install and use. So there's no really downside to that.
So Mario has a totally reasonable question in the audience. Why wouldn't UVLoop just be the standard async IO implementation then? What's the catch?
Well, I don't know what the catch is, but I could assume that it's easier to change outside of the C Python development cycle. And yeah, probably that could be one of the reasons. I don't know.
That's a good idea. Also, do you want Python itself to take on libuv as a C dependency? And then third, when I played with UVLoop originally, it's been a few years, it didn't work at all on Windows. Like its implementation of libuv was for whatever reason, it just wouldn't install on Windows. And that obviously is a breaking change or a stopper. So maybe even if it works on Windows, maybe there's like some obscure place where Python runs, but libuv won't. Think of like some small device like a Raspberry Pi or whatever. I don't know.
Yeah. And I think we're coming down to the discussion we had before about the benchmarking again, that maybe not everyone actually wants this speed or needs this speed. Maybe it's just for like very optimized production use cases, and you actually need this 4 times faster. And for all the other use cases, maybe it's your code that is slow anyway, so you don't really care too much.
Yeah, there was a discussion about a few years ago about why is requests not just built into Python, right? They're like, well, there's URL lib stuff in there, but it's way less obvious how to use it compared to just request.get done. And response.json when you get your response back and whatnot. And they debated that at the Core Dev Summit. And they decided if we put requests into CPython, kind of like you were saying, is it'll actually slow the progress and the evolution of requests itself. And they wanted to keep this nice library its own thing that could go at its own pace.
Yeah, makes sense. I think I also heard that the security there, it's easier to patch the library in like on PyPI and make people install an update than shipping a hotfix release or whatever of Python to fix those security issues.
Yeah, absolutely. And Brandon just says, I just learned that fast API Starlet use UVLoop by default. Yeah, that's what that's one of the things I was thinking of. If it's installed in the virtual environment and has access to it, it'll just take it and go. No need to make any changes there. All right, awesome. So that's just the one thing in the alternate loop section, but quite neat indeed. Then there's got to be a miscellaneous, right? There's got to be a utils. There's got to be a helpers. There's got to be something that's just like, well, what the heck is this? Tell us about the grab bag at the end here.
Yeah, there's a few here which I find very interesting. The first one here is IOChan, which adds a CSP style concurrency feature. So if you've done some Go programming, you came across channels, I would say. And this IOChan brings these kind of patterns into async IO. So basically what you will have is you can create a channel and then you can have multiple coroutines like a producer and a consumer listening and writing to this channel. And you can have it buffered or not and these kind of things. You can select on multiple channels and react on incoming data, these kind of things. So it's just another way to communicate between your coroutines than what you would probably do with the built-in mechanisms.
Sure. And a lot of those patterns are incredibly hard to get just right with the event signaling and all those things. And so if you can just hook it in, then it's good to go.
Yeah, you could probably make this work with queues and events and all these, but it's nice to have the abstraction of these CSP primitives.
Yeah, it's a sort of equivalent to saying, well, you've got HTTP server built into Python itself. Like, why do you need Flask? And like, no, we don't want to do this. Other notable ones here, like one that stood out to me is AIO cache, which is pretty straightforward. It's like just a cache, right? Add, get, set, even has a cool increment and so on. But it's async IO and it talks to Redis memcache, Redis and memcache, message pack, a bunch of different capabilities it has, right?
Yeah, it looks super cool. I haven't used it. But yeah, it's nice that you can just switch out the backends and use something else. Also, the API looks very straightforward with like just .set, .get, and
exactly. It's pretty straightforward to await a cache.get or await a cache.set. Yeah, it seems like a real nice
also
API.
The decorators seem look interesting, so that you can cache entire coroutines probably.
Yeah, exactly. That's just that I didn't really catch that before. You're right. So people are probably familiar with the Func Tools
LRU cache.
LTS cache, the LRU cache. Yes, I'm like, it's not a T. LRU cache. Thank you. But this is that idea. But instead of saying, well, where you cache that is in memory, as you just say, cache equals Redis, which is like, wait a minute. Okay, that's cool. That's really cool.
Yeah, it's cool. Just make sure the latency is lower than actually your execution time. But yeah, it looks very nice.
That's a really good point. Like if you call this a bunch of times, then the Redis is far away. Like it actually might just be slower. But the CPU will be nice and low, so you'll be fine. You'll be fine. Now this is a cool project. Another one that I really like, I think adds some important capabilities is AIO files. Tell us about that one.
Yeah, it basically provides you file API support like you have with normal like open and these kind of functions, and do it async with async IO. But I'm not sure if I read it here, but I think on some platforms like Linux, it's hard to actually implement this correctly with like epoll and stuff. I don't know if you know more about this, but I heard that it's
Yeah.
not really a big benefit actually to run it async.
Yeah, I don't know either. What it claims here is it doesn't try to, I don't think it tries to do fancy work with truly hooking into asynchronous stuff in the file. So it just says it is going to run it on a background thread, basically.
Oh yeah.
So it probably creates like a worker thread, and whenever you ask to read, it just in the back it goes open, you know.
Yeah.
And then when you say await read, it just on that thread is, you know, maybe sets an event and then does a read or something. I don't know, a little bit of like juggling background threads, but yeah. So it, in a sense, it may make it actually tiny bit slower, but if you're doing an API and the API's got to read or write a big file, that could be a problem. The other one is you know, we'll see this in a couple of things we're discussing in this section. File sometimes it might be /user/ whatever, but it could be, you know, // network server / network drive, right? It could be very, very slow, where all of a sudden, you know, unlocking that access is a huge deal.
Yeah. Does this actually support this? This library? So could you
network files?
Oh, if you have it mounted as a drive, you mean? Okay.
Yeah, exactly. Yeah, like what the thing you're talking to might actually be far away.
Yeah.
You know?
Yeah. Exactly.
Yeah.
Yeah.
It does say handling local disk files, but I bet if you mapped it in your OS, it wouldn't know. You know?
Yeah, probably will work. Yeah. What I also like here, there is also an IO path.
Yes,
package,
that
which
one actually looks maybe even cooler, right?
I think a lot of people are using pathlib these days, and IO path basically gives you an async path type, which you can just wrap around your strings or path objects, and you get the same methods, but just you can await them basically. So you can have your path.open, path.exist, and you need to use an await, and it does this for you. I don't know here how it's implemented, if it's also using background threads or if it does some magic.
It actually hook into the true IO completion ports and all that kind of business. Yeah. Yeah. So this is really cool. So you could create, we all know about path from pathlib. It's super neat. And you can ask it questions like, does it exist? Or, you know, create this directory, or is it a directory? Or you can actually say read bytes, write bytes, read text. There's a lot of things that you would do with a context manager that become just one-liners with pathlib. And this async path lets you make all those asynchronous, like await path.exists, await write bytes, and so on.
And the cool thing is they really, I think, try to be a drop-in replacement for pathlib in the async IO world. So if you've been having a code base or have been using pathlib in an async code base, it's super easy to just switch to an async version of pathlib.
Oh, excellent. It says the implementation here. Let's see. Does it tell us? It inherits from pure path, which is cool. So you could use it as an argument to some of these, some of the pieces that will take path objects directly. It takes advantage of libaio for async IO on Linux, which is probably where you care most about performance, because that's where your server is, right?
Yeah.
So I don't know anything about libaio, but yeah. That's probably some sort of native type thing going on there. Like Linux native asynchronous IO access library. Yeah, that's okay. So maybe this is not just a little bit better. Yeah, maybe it's not just a little bit better than AO files, because, well, you can work with path objects, but it has like an OS level implementation as well. That's pretty cool. All right, I'm using it. I'm using it. Looks good.
Yeah.
That looks like those are all the ones that jumped out at me. Those two that you called out, those cache and the files, or the and the path. Those three, I guess. Anything else worth mentioning real quick?
No, I don't think so. I mean, the MISC one is just a miscellaneous package in the miscellaneous packages, I would say. So
yeah,
probably
when I saw that, I thought
your thing, maybe it's in there.
It's like the meta miscellaneous. It's like or miscellaneous squared or something like that. That's right. There's a bunch of random helper things in there. That's cool. Then you have some stuff. Let me just go quickly flip through it. Like there's some stuff on writing, like tutorials and articles, and then some video talks about async IO in there, right?
Yes. Yeah, I think they're good ones. I think a lot of them are actually from David Beasley. I'm not sure.
Yeah, David Beasley has done some cool stuff with kind of recreating async IO live in the early days. Yeah. And then Yuri, who we spoke about.
Yeah, if you really want to know like how you can think about like a mental model of async IO, I think these are very good talks. Just better understand.
Absolutely. Cool. I don't know about this guy though. All right. Then the last thing you close it out with is alternative implementations to async IO, not just like a tool you can use within async IO, but there's Curio and Trio are like probably the big two there, right?
Yeah, I think Curio, I think it's from David Beasley as well, but I don't think it's maintained really. But I think it's been a nice experiment. And at the time I looked at it, it was kind of minimal in the implementation. So you could kind of digest and see how something would be done like async IO.
Okay. Yeah.
Yeah, there's Trio, which I think is still out there. And that's also why any IO exists probably, because it kind of, you can use any IO as a front end for Trio or async IO and add some more high level features on top of async IO.
Yeah, I recently had Alex from NEIO, Creative NEIO on there, and just real quick shout out for some of the things I thought was cool over there. Is it could run on top of async IO or Trio, which is cool. It also has some really interesting aspects for like converting threads into converting regular functions into awaitable things by running them on other threads. And it can either do that on a thread or it can even do that on a sub process. So you can like go and say await run process, and then you get its value back, right? Or you could do that with sort of multi-processing, or even create a asynchronous for loop over the output stream, like standard out of sub process.
Yeah, I could have used this a few times in the past.
Yes, I know. Like this is really, really neat to be able to do that. And the other thing is the synchronization primitives like events and semaphores. He says, I haven't tried it out really, but they're supposed to be a little bit less likely to get deadlocks or race conditions because they're not reentrant, basically.
Okay, nice.
Yeah, so there's a bunch of cool little helper type things in NEIO there. But well, that's pretty much it, I think, for the list. That was a lot, but a lot of good stuff, a lot of awesome stuff, wouldn't you say?
Yeah, and I'm sure there's more awesome stuff out there, like the SQLite one we've covered. You added one 5 minutes before the talk started.
I was going through. I'm like, oh yeah, this one. Like I was looking at Motor. I'm like, oh well, the stuff built on Motor. There's some good ones there. Let's throw those in, and people can vote for them if they want. But yeah, I'm sure that people listening, if they maintain one of these libraries or they're big fans and use one a lot that's not on the list, go make a PR, right?
Absolutely, yeah. I also plan to add some more automation so that we can, for example, check for dead links. It would also be nice to kind of catch outdated libraries like the IO mock we've seen before.
Yes, exactly. Like, if it hasn't been touched in 6 years, it probably isn't needed anymore, right?
Exactly. Yeah.
Cool. Yeah, awesome. I mean, this is a great resource, and I sort of shouted out the popularity of some of these projects to give a sense. Like your list's got 3.7 thousand stars. Like that's pretty awesome. That's a lot of people who got value from it.
It is, and I can only recommend to look at these lists. Whatever list it is, there are gems in there, and it's kind of nice to discover them.
Yeah, absolutely. Really quick, out in the audience. Matos Logic says Starlite is an async framework built on top of Starlit and Pydantic, which is a good candidate. I didn't actually give a shout out to it, but I thought, oh no, it's not on there. Okay, well, they do PRs. PRs are accepted and reviewed. Starlite. There you go. Cool. All right. Well, Timo, this is really excellent project here. A ton of people are getting value from it. So thanks for putting it together.
Yeah, thanks to all the people who suggested awesome stuff. So I'm, as I said, merely the maintainer of the list. So keep them coming, and we'll make it even better.
Excellent. All right, before we get out of here, final 2 questions. I feel like you could just randomly pick one from your list, but the notable PyPI project you want to give a shout out to?
I think it's not even on there, but it would be Tenacity. If I pronounce it
Tenacity is good. Yeah.
It's a library for retrying stuff, and I think it has async. I'm pretty sure it has async support.
Okay. Let's see.
But it makes it super nice if you have like network calls.
Async retries. There you go.
Yeah, so it's even the same decorator, which is cool from an API perspective. I don't even think you have to import something else, like something differently. So because you can actually inspect the function which is being decorated, and you can decide what to run. So yeah, pretty cool. I suggest you use it if you want to retry something or have like unstable endpoints or whatever. Yeah, has all the features you need. Probably.
This is a great library. You know, if you're consuming someone else's API and that thing is flaky, you know, what are you supposed to do, right? You've got to call it potentially, but you can't count on it always working. I've run into that problem on a lot of my projects as well. And I've either done something like Tenacity, where you just say retry it with some kind of exponential backoff, or I'll go through and cache it in my database and say, I'm going to try it. If it fails, I'm going to go get it from the database and go, it might be a little bit stale, but at least this way, you know, if it's something kind of stable, like a currency lookup, like, okay, an hour ago, the dollar to Swiss francs, the lookup was this, and it might not be perfect, but it's better than just going 500 server error, you know?
Yeah. And I don't know how many like while loops I've written in my life to kind of check a timeout and retry and sleep and these kind of things. And it's hard to get this right because, you want to catch termination of the program and cancel these things. So it's nice to have a library for all these.
Yeah, cool. And the fact that they support async is like perfectly blends in. Yeah. And then
as well.
Yeah. Actually, it would belong to it now. All right. And then the other question is, if you're going to write some Python code, what editor are you using these days?
These days, VS Code. It's important, though, that it has Vim key bindings. I've been a Vim user for quite some time. So I certainly need that. But VS Code is my editor to go these days.
Awesome. All right. Final call to action. People are interested in your awesome list. What do you tell them?
Please contribute your awesome ideas. Make a PR. Also, if you have ideas around automation, please send them our way. Create a pull request.
Yeah, that's a good idea. Nice. As a maintainer, that's a very welcome thing, right? To find things you don't have to maintain, I'm sure.
Absolutely, yeah.
Awesome. All right. Well, thanks so much for being here. Thanks everyone to listen. Yeah, bye.
Bye.